Should you minimize code to troubleshoot difficult bugs? Imagine trying to find a tiny needle in a huge haystack. That's what debugging can feel like when your code is complex and full of many parts. Sometimes, the best way to find the problem is to make it smaller. Minimizing code means cutting down the program or the problematic section to the smallest version that still shows the bug. This helps you see exactly where the issue is hiding. When you remove unrelated parts, the bug becomes clearer and easier to understand. Bugs often happen because of tricky interactions between different pieces of code. When you minimize, you narrow down where the bug could be. This process is called localizing the issue or isolating specific modules. By focusing on a smaller, simpler code piece, you cut down the number of variables and potential error sources. That makes testing and fixing much faster. Minimizing code works well with good debugging practices. For example, narrowing the scope means you can create a minimal reproducible example. This is a small piece of code that still causes the bug to happen. It helps you see the problem without extra clutter. Divide and conquer is another approach. You break your code into smaller parts and test each one separately. Minimizing is a natural step here because it helps isolate the problematic section. Incremental testing is also useful. You write small code modules, test them, and then add more. If a bug appears, you know exactly where it is. To minimize code, you might remove features or modules that are not related to the bug. Simplify input data or test cases to the smallest from that still triggers the issue. You can comment out or temporarily disable code sections to see if the bug still happens. Sometimes, creating a separate minimal test program outside the full application helps reproduce the bug more easily. This approach is especially helpful when bugs are hard to reproduce or happen in large, complicated systems. It reduces mental load and makes debugging tools like debuggers, loggers, or static analyzers more effective. But be careful. If you cut too much, you might remove the conditions that cause the bug, leading to false conclusions. In the end, minimizing code is a proven strategy for troubleshooting tough bugs. It helps you find the root cause faster by reducing complexity and focusing your attention. It fits perfectly with methods that emphasize localizing issues and testing small parts step by step. So, when you face a stubborn bug, try shrinking your code first. It might just be the quickest way to solve the problem.